Hello Internet friends, welcome to our second video in our journey of creating fully functional desktop application. In this video, I'm going to demonstrate how you can use the built-in data types, how you can use variables, and actually start writing code. So let's begin. The state of the application previously is that we were able to add label on the form, and when we run the application, it just show a hello world label. For this video, I want another form. So I don't want to change this one. I want a brand new one. I can do that by selecting the project, right click, choose add, new item, and in the new item form, I can select Windows form and form. I'm going to name these primitives and press enter. So now I have two forms. Form 1 from the previous video and primitives that I want to use this video. However, when I press start, now the application will run the old form. Will start the old form, the hello world form. In order to change, in order for this to be changed, I need to go to the program file, and you will see 3 rows of code. In the last one, there is application run command that initiates new form 1 class. I want this to point to actually initiate new primitive class. So I can do that by selecting the form 1 and typing. You notice that Visual Studio is intelligent enough to give me several options, and it's already highlighted the one possibility that I can use now, that is the primitives form, which is what I actually want. So in order to use that, I don't want to type everything. I'm going to just press tab, and Visual Studio will fill in the other characters for me. So I'm going to save this and press start. So now when I run the application, the primitives form will run, not the form 1 that was used to display hello world. Okay, so in this form, I want to add 2 controls for now. So I'm going to select that. I want 2 controls. From the toolbox, I'm going to drag and drop label. I'm going to change the size. That is under font property, size. I'm going to, let's see how it's 22. It's okay. I'm going to change the text from label 1 to. So if I run the application now, I will see this text as we saw that for hello world. The second control I want to add, it's a text box. So the idea is that I'll use this text box in a similar manner as when you learn C# program or other program that uses console application and you see the text on the console itself. So this text box will be a replacement for that. I'm going to build the text behind, and I'm going to use the text box just to display the text. So obviously this needs to be bigger. So I'm going to increase the size. The position is okay. However, there is only one line. Obviously, I want multiple lines. So you'll notice I'm not able to increase the height of the control. Let's return this to That was. So if I want to increase the height of the control, I need to go to the property and choose multi-line. I need to change this property from false to true. You'll notice now that I have more options, and I'm going to press and hold the bottom line, and I'm going to drag that a bit lower. Let's increase it a bit. Okay, so this form now has two controls, label and text box. And if you run the application, you will see those same controls. You will also notice that the text box is actually accessible. So I'm able to write anything in the text box. But I want to use this as a display output, so to speak. I want to just to show a text that I'm going to build in the code behind. So in order to do that, I'm going to change another property. I'm going to select the control and choose the write-only property to true. Now if I run the application, I'm no longer able to write anything. Okay, that's good. So let's start writing the code. So if I want to go to the code behind, I'm going to press F7 on my keyboard. And this is the file you're going to see. It will tell you that the form that I have created, it inherits from the base form class, but we'll talk about later. There is constructor, we'll talk about constructor later, and there is function that runs immediately. This is initialize components. This is actually the form that is used to write all the controls on the form. So this runs, so you can see all the controls that are on here. What you want to do is add code after this, because you don't want to add code to a form that is not initialized. It will not work. Let's start by declaring some, you can say, fairly often or rather regularly used built-in data types. For representing numbers, um, there is a bit larger selection that I'm going to show you here, but with everything I'm going to show you here, you should be able to pretty much develop all your application you want. Unsigned numbers, if that is something you need to use. There are built-in types for that as well, but they are not that often used. Anyway, the same approach I'm going to show you now applies for the other built-in data types. So basically, I'm going to create a couple of variables, and I'm going to assign values to them. So let's start with the first one. This built-in data type is used to store short integers, around 30,000 and so. So if you have a number that is below that value, you are okay to store it here. If not, and you think that you need to store bigger values, look at using different built-in data type. So let's declare this as so s number is actually the variable that is from declared as a short data type. So I need to initiate this, so I can add the value 77. Unlike in mathematics where it says the left side and the right side are the same, in programming, equal sign means that you are assigning the right side to the left side. It makes a difference, and during this coding you will notice that. For representing about around 2 billion and such, more than 2 billions numbers, you can use the int built-in type. Okay. I'm going to assign the same number, and if you want extremely long numbers, you can use the long built-in data type. For representing decimal values, you can use float, and this is kind of interesting. If you add decimal number, you will see that it is underlined red. This means that this has a problem. It cannot compile. Basically, the decimal numbers in C# default to double precision because for the single precision it will not accept this value unless you specify that you want this to a single precision number. You can do that in this case by adding F at the end of the number. So if you use double, you can add the same number without any issue. If you like, so obviously the float is single precision, double is double precision, but if you really need precision in the decimal field, you would like to use the actual decimal built-in data type. In this case, as in float, you will notice that the decimal number is causing an error. That is because as I mentioned, the default value of the decimal number in C# is double precision. So you can specify that you want this number to be decimal by adding M at the end of the number. Okay, so the other built-in data types you're going to use are string, characters, and such. Let's just declare one string. So string is basically used for text. So let's just add text here. And if you like to have a boolean values, you can use the bool built-in type. So how to name this? Okay, boolean value. Now let's make this true. Okay, so we have initiate declare variables and added values to the variables, and now we want to show them on the form itself, because at this point if I start the application, this will do pretty much nothing, or rather you will not see anything in the form itself because they are not assigned to the text box. Okay, let's start adding these values to the text box. So for that, I'm going to name the text box something I can easily remember. I'm going to change the name property from textbox1 to okay. And if I go to the code behind, I can add the text of the TextBox control to the text property. So I can do that by in this case, Visual Studio did not uh, highlighted the TB primitives. Um, so I'm wondering, did I make a mistake of naming? No, looks okay. Okay, sometimes it can happen. So in the TextBox primitive field or property, I can add the as text value. So all this is saying is left side of the equal sign assigned to the right side. Sorry, the right side of the equal sign assigned to the left side. So if I run this, you should see hello YouTube viewer text in the text box. Yeah, here it is. Okay, so let's change this. So I want all these numbers to be visible. So I'm going to add new line. I'm going to add new line by typing environment dot new line. This will add new row, or rather it will move the cursor to a new row. Now I'm going to add plus sign. That is how you can concatenate strings. It's the simplest approach. You have two strings or um, two variables, and if you use strings, most of the time the variable will be converted to string. So in this case, I want to say to add another string. So this is the fixed text that will be printed, and I'm going to add the value of the variable as number. I can do that by simply adding plus and the name of the variable. After this, I want the cursor to be moved to a new line, and I can do that by just typing the same command here, plus environment dot new line. And I'm going to do this for the other numbers. Okay, I have forgot to add new line here. I'm going to do that now. And each command needs to end with semicolon. Oh, okay. I need to add will print the boolean value as well. So if I run the application now, you will see um, all the numbers I have declared in the code behind are written. And it follows the same approach as the console. So yeah. Okay, so I have declared different data types. I have used different data types, different variables, but I'm pretty much using the same number, give or take. So what is actually the difference? Can you actually notice the difference between these built-in data types? So how about this? How about we print out the lowest and the maximum number that each built-in data type can represent? We'll skip the boolean now. And I can do that by creating another set of um, variables. So we can do that like this. So I want to take the minimal number that this built-in data type can hold. And I can get that value by typing the data type dot, and I can choose min values. This is a property, and I can pull the data here like this. Oh, yeah. Once the variables are declared, you cannot declare them again. This is a mistake I've made. So I wanted to create a new variable, not to reuse the same one. So I can do this, L number main. And I want this to be visible in the text box. I'm going to write I want to add 2 new lines. I'm going to add the s number main plus new line. I'm going to add new value of integer. I'm going to add new line. This this is the minimal number for long. I'm going to add new line. I'm going to add the minimal number of double plus new line. Uh, okay, so I'm going to add the minimal number of decimal. Okay, finally. So we have created another string of text. We added the numbers in the string, and because we are concatenating strings, this will be represented as a string. So when I run the application, okay, so this is interesting. The primitive text, this one, has overwritten the primitive text we have created previously. The situation is that I want all this to be visible and the new text to be added, not to override the previous text. But in this case, this was overwritten. Why is that? Well, the simple factor is that, let's close this, you can reuse variables. So, for instance, the same variable, hello, this is YouTube viewer, right? I can go here and I can reuse the variable and I can add this text to the same variable, and instead of having this text here, I can just use the st's variable. Also, this should have had a new line. But to get back to the why this was overwritten with this. But the same thing happened here. Like I'm going to override the hello YouTuber with the right side of this command, the same happen here. So I want to preserve the first string and attach the second one. I don't want to override that. So I can easily do that by just adding the previous value of the primitive text of the text box. I can do that by just saying I want the primitive text box to be assigned the primitive text values plus everything else. This is the previous state of the text box field, and this will be the next one. So if I run the application now, we'll wait a bit. But now you see everything that was added in the first time I have assigned the values to the text box, and the second time I have assigned values to the text box. The same thing as that happened when I reuse the stext variables, where I assign value initially here, you can see it here, and then I change the assigned value to here. That is it here. Okay. So that were the minimum values. Let's add them at the maximum values. So I can write short as number max, and for again I can use the short dot, this time max value, to pull in the max value. So I can use this for all this. I'm going to change this, just the name of the variables. And I'm going to change the parameter from the property from which I am pulling the number. So previously I was pulling the number from the min value, now I'm pulling the number from the max value. And I want this to be added to the existing text box, so I don't want that to be overwritten again. So I can use this approach. Or I can just use this. Basically, this is command that is saying, okay, the value of the text box will be the value of the text box, the previous state, plus it will add the new values. So for the new values, I'm going to, okay, let's reuse the S text again. And I can reuse the previous code. I'm going to just change a couple of things. Okay, now we are ready to show the minimum and the maximum number for each built-in data types. So here is also something interesting. The um, first time we try to assign values to the text box, we can see that. The second time, we can see that. The second time we added string to the text box, that was added as well. And the third time was added, but it's not the whole thing we wanted to print. Well, actually, it is the whole thing we wanted to print, but because we have set the text box height as a fixed value, um, it cannot show you something that is below the last line. We can fix that by, okay, this need to add another environment new line first. And now to fix the text box, we are going to go to the property. Okay, here is the property I was looking for. It's the screwball property. Currently it is none. I want to have vertical scroll bar. So you see here uh, that the text box now has a scroll bar. If you run the application, did I forget to add terminal command? Yeah, I forget to add plus. So you'll see the first thing we added is here, the second thing we added is here, and so is the third thing. So we can scroll now. And you can see these numbers are pretty huge. Um, yeah, from the lowest numbers to the highest numbers, you can choose the data type that is appropriate for your needs. What else can we do? Okay, we can let's print out how much bytes um, each data type use for storing the numbers. So to do that, I'm going to also demonstrate another approach how you can declare variables. It's not my favorite way, but if you like, you can use that as well. So I need only integer numbers for this. I can use short, but yeah, int will do fine. I'm going to print the bytes of short, so I'm going to say s bytes. I'm going to declare variables for integer bytes and for other types. You'll notice that previously I have created variable and I have assigned them values in the same line, or rather I have assigned values when I have declared the variables. I can declare variables without assigning the values immediately, but I still need to assign the values. So as I'm able to, oh, as I'm able to create variables at the same time, I can assign value at the same time, and I can use the equal sign, which obviously is not equal, it's assigned value. So I can do that like this. I want S bytes to be the same as I bytes to be the same as L bytes, and so forth. And I want all these variables to be assigned value of 0. So basically what is happening is that the 0 value assigned to DC bytes, and that value is then assigned to D bytes, and so on and so on and so on. I prefer this approach where you kind of create the variable and assign value at the same time. But you can use this approach as well. So I can pull the number of bytes each data type uses. So I can use a function in C# for that. So to get the bytes of how many bytes the short data type uses, I can just write size of and add the name of the data type. Oh, yeah, we need equal. And I can do this for the other data types. Okay, now we have the values and I want to print them. So we can use the same approach. I'm going to write this code. Now we'll write for double. And we need to write for decimal. Okay. However, short data type uses, what does it uses? So I'm going to add, I'm going to copy this. And if we run the application now, we'll see how many bytes each data type uses. Okay, you'll notice the decimal uses 16 bytes, which is significant. And obviously we need to add empty space between the numbers and the bytes. We can do that by just adding empty space here. So now when we run this, there should be an empty space between the number and the bytes. Oh, yeah, here it is. So how about, yeah, I can actually illustrate what is the difference between and why it is important to be aware how many bytes each data type uses. So, okay, for that, I'm going to do this. I'm going to increase the height of the form and I'm going to copy. I'm going to select the label and the text box, Control C, Control V. I'm going to um, put them a bit lower. So I need this to be, did I change the name? Oh, it was not important. Usually you would like to assign a name so you're aware of the name of the control because it makes it easier to when you're debugging or especially if you have thousands and thousands of line of code. But for this purpose, yeah, we are okay with that. So let's make a benchmark. I'm going to name this control because I'm going to use this. What I want to show you is what is the difference between. I'm not going to show you for all these data types. Let's just use integer, double, and decimal. So yeah, I'm going to show you how much time it takes for you to calculate something using each of those data types. Obviously, the PCs nowadays are kind of quite a lot faster, so we need to do this for a couple of millions of operations rather than just a couple. But you will still see some differences. So For that, the idea is for to create to run the same calculation each time. So let's just use um, addition, multiplication, and division. Why not? So I'm going to use I'm going to declare um, three variables for each data type. So I'm going to declare three variables for decimal. So how I'm going to do this? Um, so the idea is to capture the time before you start the operations and then capture the time after you start the operation and then just um, use simple arithmetics to find out how much time it passes. Obviously, if even if I use millions of calculations, this will be in milliseconds. So okay, let's start with addition. So in order to execute, let's say 10 million, this is command that can be used to iterate over and over. I'm going to skip the explanation for now. We'll revisit this later when we actually use it for something more practical. For now, all I want is to just execute the same command 10 million times. So let's say it's equal to, why not? And I'm going to repeat this for the other two data types. For in this case, I'll use okay. But how do I actually calculate how much time it passes? For that case, we can use that by using time span. So we can declare we'll create a new object of the time span class, and obviously we don't want to use two equal signs. Oh, I deleted the wrong one. Man, I need a break. Okay, so time spent for the integer. I'm going to do the same for the other two types. So this is for us to get the total millisecond seconds that will elapse. But we also need a way to capture the start and end time. So we can do that by creating a datetime property. Okay, but we need to have end and start datetime. I want this to be the start for the double. Oh, yeah. We don't need to create separate ones for addition and the other operation because we'll pretty much reuse them. And before each iteration starts, we are going to say oh, this is start and is equal to datetime now. This means that we'll assign the null value at the exact time to the dt int start variable. And we will do the same for the end variable. And we can use time span to extract the difference. So we can use that will be datetime int start sorry, other way around, datetime int end minus datetime int start. So this will be the values that will hold how much time it passes for our program to calculate 10 million times the same calculation. And we can do the same for double. We're going to assign null property. That is for the double, and for decimal we repeat this. Okay. So, okay, now we have set up the calculations and we set up a way how we can find out how much time it takes for each calculation to take place. But we want to show this on the screen. So we can show this on the screen by okay. And we want to add new line and did I make a typo when naming this? Yeah, I made a typo. Okay, we're going to add. So I'm going to use the time span variable, but I want to extract property, or we'll use total milliseconds. Okay, and I'm going to add new line. Going to copy this and use the same for the double. And I'm going to use the same for decimal. Obviously, the statement says to decimal numbers, but pretty much all integer number by default are decimal and double numbers because each decimal and double number can hold integer. I can change this decimal and double numbers to be with decimal part. But I'm thinking, yeah, we can use the same approach with the same numbers for calculations. So at some point, by calculating double and decimal numbers, when you use their native types, we can do that. But I wanted to have everything the same. So let's run the application. Hoping 10 million is not that much. Yeah, it's not. So these are in milliseconds. You'll pretty much see that they are pretty much very similar. Okay, let's do this for multiplication. I'm going to just straight up copy everything. And I'm going to change the things I need to change basically. Um, okay, I wanted to say oh man, I really need a break. Okay, now I'm going to use the multi. So this is the, let's make it this more visible. This is just adding a comment, nothing special. Double slash, it means that this will not be included in the compile code. And we are going to multiply the same numbers. Why not? The same should work because we are using the same values. So, but because we changed the necessary values, we can pretty much run the code now, and we should see the multiplication. Yeah, I did the same mistake? Yeah, I did the same mistake. So basically, yeah, here it is. When I copied and changed this line, I did not include the previous state of the text box. So now we should be able to see the multiplication and addition values as well. Is addition, these are multiplication. You'll notice that multiplication are a bit, uh, it takes a bit longer to multiply. So let's see how big of a difference is when you have a division. So we're going to copy all this. Um, I wanted to add another new line so it is more visible. Obviously, this will be division. We cannot add decimal value in the integer field, so we're going to remove that. So now we are just going to see double and decimal values. So if we run this, now we have the values for the division. And you'll notice that in each scenario the decimal arithmetics is a bit slower. So having a large number of calculation using the decimal values can have impact on the program you are trying to write. For start, you're okay to use pretty much anything, but when you start getting more serious with the application, especially if you're trying to optimize, it is very important to choose the correct data type to represent your numbers. Oh, I can demonstrate some of the problems where you may face um, when you use built-in data types to represent numbers that cannot hold the values that you are trying to add to the numbers. Um, okay, we can pretty much hide all this, so we can use this command. And if we scroll down and add, so we just created a region for the code. This is useful because when you need to scroll a long way up and down, and when you try to just focus on some part of your code, it adds a lot of unnecessary clutter. So you can tidy up a bit by creating regions. And you'll notice there is a sign on the left side, so we can just press that, and all the code in the region is now collapsed. So I can just focus my attention on the code I want. Okay, so let's create a couple of calculations. So, okay, I'm going to declare int value, and this value I want to calculate um, addition between integer value and long value. Actually, I want to add the maximum long value just to see what will happen. So I'll add, let's let's reuse the numbers we have created. So I'll add the number variable and I'll add the L number max. This should be 77 and this should be a very big number. Immediately you will see that Visual Studio is saying, okay, you have potential problems because integer cannot hold the whole value of the long type data type. But it's still permissible for you to change or rather convert one data type to another. So I can just convert this to integer by adding this, adding int in bracket before the number. So this will calculate, however, it is obviously that this number cannot be represented by integer because integer is way too short to represent all the numbers. So if you have this situation, you will be able to execute your code, but you must see problems in edge cases where um, the numbers of the one variable exceeded the capacity of the built-in data type you're trying to use to take all the calculations, like in this case. So what else I can demonstrate? Well, the same approach applies to other data types, so you can try that yourself, I presume. But um, let's just demonstrate this. So I'm going to add this will be demo for overflow. Let's print out the real numbers. So I'll write this. So if we run this, so you will see that this whole number, when we add this number, when we add 77 to this, we will only get 76. That means that the whole number overflow. And this is one thing to be careful about when you are actually mixing data types. Because you can obviously make the application run. Uh, there are lots of legitimate reasons why you will need to convert from one number to another. but just bear in mind that strange things can happen. And yeah, okay. So one thing before we conclude, um, so we can just when we run the application, you will notice that the first text box control is selected. So if you don't like first text box control to be selected, you can just um, switch the focus to another control. So I can switch the focus. Let's go after the benchmarks, right? So I can just write this dot after active control is equal to I did not name the yeah, I did not name the label control. So I'm just saying the active control of this form will be label control. So now when I run the application, the text box should not be selected, and it is not. Okay, that was enough for this video. In the next video, I will continue. With demonstrating other functions of the WinForms applications before we can continue working on the George application. So yeah, we'll continue with the WinForms a bit later. Thank you for watching. I hope you like this video. If you have some idea for me to show more in details, or you have more you like something to be explained in more details, just drop me a comment. Have a wonderful day and see you in the next video. Bye.